Okay, wait, I'm just going to turn off my camera. All right. So let's start. First off, let's do question 5. Sophie.
Okay, first we know that a total of age of Anne, Bob, and Chris is 31 years. So then, what would be the total of their ages in 3 years' time? So then, we all know that by 3 years when we pass, we'll be 13. Well, for me, of course, I'll be 13. So that means that every single person will grow 3 years. So then they're asking for the sum of all of them in 3 years. So then we add 3 years to all of them. So then we don't know, of course, what the name is. So then we just add the age is. So we just add them together, which gives us a total of 41 years. 40 years, sorry.
Yeah, all right, great. So next question, question 6, Yuki.
I can't, can I control your screen?
Yeah, okay. Do you know how to control my screen?
No.
You can go to annotate.
Yeah, so basically, like on probably at the top of your screen, there's like you are viewing Qishan's screen, and then you press view options, and in view options, there's this button called annotate.
It's not there.
It's not there? Okay, then
Yeah.
you can just like talk, and I'll like write for you.
No, you can always give her remote control. Like you can also give her remote control if you want. I don't know if that will work though.
Or you could share your screen.
Sorry, I just did something.
Okay, can you?
Okay. I think it's...
Okay. All right.
Oh my god. Okay, there you go. Is it working?
Yes.
Okay, good. I don't know how to start.
Okay, so I'll read the question first. The G's have 3 little daughters. Every daughter has exactly 2 brothers. How many people are there in the family?
Okay, so it's like they're one family, right?
Mm-hmm.
And there's 3 daughters. Each of them have exactly 2 brothers. There's actually only 2 brothers in the family because
Yeah, that's right. So because every daughter has exactly 2 brothers. Okay,
yeah.
go on. Mm-hmm.
And then that's 5 people. Then there's like the mother and the father. So 7.
Okay, good. All right, Sean. You could also explain. In 1 sec.
Okay.
Wait 1 sec. Wait, I'm just going to stop sharing my screen and share my screen again. Oh, oops, my bad. All right. Okay, good. All right. You can continue, Sean.
Wait.
Okay, so this question, I think it's like trying to trick you to thinking that each daughter like has two brothers. So like every single daughter has two brothers, and that would lead to like 6 brothers. But that's not the case.
Yeah.
So the real okay, can I draw?
Yes. Of
Okay.
course you can.
So S is sisters. And then since they're all the same family, that means that there's basically only 2 brothers.
Mhm.
So 2 brothers. Yeah.
All right. Great.
But what if it's a single parent?
Oh, okay, wait. Just before we go on, so I want to say that Yuki helped us point out, like, what about the other people of the family? For example, like parents. What if the grandparents are part of the family? So Yuki helped us point out that, like, she said that there might be parents in the family, but there could also be grandparents in the family. So this problem isn't worded really well because it's not defining what a family is, right? So, and also we saw Sean point out the wording. Every daughter has exactly 2 brothers. So every daughter has exactly 2 brothers. And it says every daughter every daughter has exactly 2 brothers. The wording is different from for every daughter. There are 2 brothers. So the bottom one is a ratio. So for every daughter, there's 1 daughter. There are 2 brothers. So it's a 1-to-2 relationship. And up here, every daughter has exactly 2 brothers. So then it could be common brothers between the 3 daughters. Right. All right, number 7. Harrison.
Okay. So, as the question says, it says that Michael needs to take a pill every 15 minutes. And he first took his pill. Wait, I can draw.
Okay.
So he first took his pill at 11:05. And now it's asking when did he get his 4th pill. So I pretty much did this step by step. So I added 15 minutes to it. And I got 11:20. And if you keep on doing that, you'll eventually get to 11:50.
Okay, great. So I think that's also clear. And now going on to the questions. Oh, if you have problems on, we're going to go on to question 25. Question 25. A stack of loads must be transported. If Anne does the job alone, it will take 1 hour. If Ben does the job alone, it will take 2 hours. How long will it take if Anne and Ben do the job together? So first off, let's look at how each person does their work. So Anne's speed of doing the work is J divided by H. So for for every job, Anne takes an hour because that's what it says in the problem. And B is J divided by 2H, which means for every job Ben does, Is it Ben? Yeah, it's Ben. For every job Ben does, it takes him 2 hours. So if we want to compare the speed together, we have to convert it into a common unit. For example, J per H. So jobs per hour. How many jobs per hour? So how can we transfer this into a jobs per hour? So if we break it down, it's actually jobs times 1/2 times 1/hourth. Just like 1 over an hour. So that means if we want to turn it into a J divided by H, job divided by hour, then we do J times hour, 1 divided by hour, because like you can rearrange J, 1/2, and 1H any way you want. So this equals 1/2 times J over H. And now, so we have like the two speeds. So if we compare them, we have J over H to 1/2 over J times J over H. So if we divide J over H on each side, we get 1 to 1/2. And if we multiply 2 on each side, we get 2 to 1, which means that the speed of A to B is 2 to 1. So for example, if B does a unit of work, then that means A does twice the units of work. So now we have that in mind, we see that for every unit of work, if A and B work together and B does 1 unit of work, then together they will do 3 units of work. So why is this important? Because we want to find out 3 units of how much work equals the whole work. Which means basically like we have the entire work is split into 3 parts. So if it's split into 3 parts, then it's 1/3 of the job. 3 1/3 of the job. So we see that if we put the 3 1/3 together, it equals 1. Just 1 whole of the job. 1 job. And since it's asking how long will it take Anne and Ben to do the job together, we're looking for 1 whole of the job. Which means that Ben has to do 1/3 of the job, and Anne has to do 2/3 of the job when they are finished. And then it's asking how long will it take Anne and Ben together. So the amount of hours it takes, we have to look at the speed of either A or B. Probably A is easier because it's the unit speed, jobs per hour. So let me just erase this first. So we have jobs per hour. So how much time will it take for A to do 2/3 of the job? So if we multiply 2/3 on the top and the bottom, we get A does 2/3 of the job per 40 minutes, because an hour is basically 60 minutes, and 60 minutes times 2/3 is 40 minutes. So when A does this much work, so when A works for 40 minutes, A will do 2/3 of the job. And when B works for 40 minutes, B would do 1/3 of the job. So that means the answer is 40 minutes. It will take A and B to do it will take A and B 40 minutes to do the job. Do you guys understand? All right. Next one. Number 23. There are 4 buttons in a row as shown below. 2 of them show happy faces, and 2 of them show sad faces. If we press on a face, its expression turns to the opposite. In addition to this, the adjacent buttons also change their expressions. What is the least number of times you need to press a button in order to get all happy faces? Okay, so we look at all the ways we could do this. First off, we need to make an expression for the faces. Let's just say that sad face means 0, happy face is 1. So it starts out in the position 0, 1, 0, 1. So this is just like binary, like it's just like binary, which computers use binary, and it's like basically inside the computer there's on off switches. So if a switch is on, then that means it's 1. If a switch is off, then it's 0. So you can do the same thing here. If the button is sad, then it's 0. If the button is happy, it's 1. So first off, we have the starting position, 0, 1, 0, 1. And then there are 4 possibilities of pressing these buttons. So there's the first possibility, pressing this 0. So if we press this 0, we get 1, 0, 0, 1. Second possibility is pressing the 1. So we get 0, 0, no, 1, 0, 1, 1. Excuse me. And the third possibility is pressing this 0. So then we get 0, 0, 1, 0. And the fourth possibility is pressing this 1, which we get 0, 1, 1, 0. Okay, so second step. What could we do? So now, obviously, like for this configuration, since we pressed the leftmost number, if we press the leftmost number again, we're going to go back to this position. And since it's saying what is the least number of times you need to press a button in order to get all happy faces, we don't want to waste extra few steps, like making your digits like go back to what it was before. So we look at this 1, 0, 0, 1. What if we press this 0? If we press this 0, this becomes 0, 1, 1, 1. Alright, and now we look at this. And oh, never mind. So if we continue on, we could also press this 0 and there will be the same effect. And if we press this 1, it's basically the same thing as this configuration, except the opposite way around, which doesn't really make much of a difference. So this is basically the only possibility we get if we count configurations that are basically the same, just flipped around. Alright, now we have 1, 0, 1, 1. So if we press this 1 here, then we get 0, 1, 1, 1. So, but if we press this 0 here though, then that means we go back to the original position. If we press this 1, then that means it's going to be 1, 1, 0, 0. So we can also have 1, 1, 0, 0. Alright, and notice that these two possibilities are the same. So basically we can draw an arrow over there. Or we could have, it was 1, 1, 0, 0. And at last, if we press this button, then that means we get 1, 0, 0, 1. No, 1, 0, 0, 0. Right. Okay, so now moving on to the next one. 0, 0, 1, 0. So it's basically the same thing as this thing, except that the zeros and ones are opposite, if you realize. So first off, 0, 0, 0, 1. What could it become? It could become this, but opposite, because this is the opposite of this, if we flip it around. So then it could become a 1, 0, 0, 0. Or it could be 1, 1, 0, 0, except flipped around, which is still basically the same thing, 1, 1, 0, 0. And then we can also have 1, 0, 0, 0 flipped around, and that is 0, 1, 1, 1. So then, after that, we get 0, 1, 1, 0. 0110 is basically the same thing as 1001 but flipped around, which means then we get 1000. So then we have these three outcomes. 1000, 1100, and 0111. And then next step. So let's take 1000 for instance. Then we could get 1111. See, that's 3 steps. And we don't need to go any further to determine what the other possibilities end up. Because we know that 3 steps would be the minimum amount of steps because we already found all the possibilities for 2 steps, which was 0111, 1100, or 1000. So that means 3 steps is the minimum amount of steps you need to get all the faces to happy. All right, do you guys have any questions? I know that was a very long explanation. Okay, so now moving on to question 19. Can somebody read question 19? No? Huh?
During the final game of a soccer championship, the team scored a lot of goals. 6 goals were scored during the first period of the game, and the guest team was leading the score at halftime break. During the second period, the home team scored 3 goals, and as a result, they won the game. How many goals did the home team score altogether?
All right, so first off, let's see what information it gives us. So 6 scores were scored during the first period of the game. So A plus B equals 6. And then A is smaller than B because the guest team was in the lead. And then during the second period, the home team scored 3 goals. So 3 goals. And as a result, they won the game. How many goals did the home team score together? So first off, we look at A and B. What could A and B be? So A and B could be 0 and 6, 1 and 5, or 2 and 4. Because note, A and B are whole numbers of goals. You can't score half a goal. So we look at these numbers. If we know that home team, so then we see that A plus 3 is larger than B. So home team won. And also it could be like B plus 1 or plus 2 or whatever, but we're looking at home team. So how much did home team score? All right, so if we use 0 and 6, obviously no, because 0 plus 3 is not larger than 6. It's the same as 1 and 5. 4 is smaller than 5, not larger, because if we plug in 1 and 5, it doesn't make sense. So so we're down with 2 and 4, and 2 plus 3 equals 5, which is larger than 4. And then, so that means the amount of goals home team scored was 5. So there we go. All right, number 24, because we're going backwards. 40 boys and 28 girls stand in a circle, hand in hand, all facing inwards. Exactly 18 boys give their right hand to a girl. How many boys give their left hand to a girl? Okay, so let's say that, for example, we have a person, let's say a boy, and then it's facing inward, which means that the right is on our left and their left is on our right. Because if they're facing inward, and it's like at the top of the circle from where we look, it's basically like it's basically looking at the opposite way of what you are. It's looking like backwards to you. So anyways, enough of the chatter. And then 18 boys have a girl on their right. So it's like this. So how are we going to solve this problem? So we can consider, first off, let's put 18 pairs together. So we'll define each pair as a girl whose left has a boy. So this is one pair, which means that we have 18 of these pairs. So then let's just say all 18 pairs were lined up together. So like we have 1, 2, 3, ... So these are the 18 pairs. And then we still have other students. So we have 40 minus 18 is 22, and 28 minus 18 is 10. So there are 22 boys left and 10 girls. So if we clump all the girls and boys together, then that means there's no boys who are on the left of a girl. So, but you're like, well, there's an adjacent girl and a boy over here. Well, as you see, this is the girl's right, not left. The boy is on the right of the girl, not the left of the girl. And the starting there's the 22 boys group and the 10 girls group. And at the start of the pairs, we have boy and then girl, boy, girl, ... all the way to boy, girl. So this is the general model we could use. And then it's asking how many boys give their left hand to a girl. So that means, but we should first look at like this group. So in this group, how many boys give their left hand to a girl? How do we figure it out? Well, it's pretty easy. So for example, if we have boy, girl, then that means we reform groups. So like the boy, it was supposed to be like this. We make it this. Which means that in the end, there would be a boy and a girl left out. Since we're looking at the amount of boys, then we know that if there are 17 of these groups, so 17 times 2, there are 17 boys who give their left hand to a girl, which is in the groups.
But that's not an option though.
Yeah, I
That's
know
not
it's
an
not an option, right? So you're correct. It's not an option in the list. So we now need to see what did we miss. So looking at the boy on the end, the boy's left side, there's another boy. And so like we could group the boy together into the 22 boys, making 23 boys. But then remember when we said that there was a boy that was connecting to a girl, but the girl was not on the right side of the boy, but it was on the left side. So that's just one more group we need to count in. So we add 1, which is 18. All right, so that was a good question, Sophie. Do any of you guys have any other questions? No? Okay. All right. Number 22. Harrison, can you please read question number 22?
Okay. 66 cats signed up for the contest Miss Cat 2013. After the first round, 21 cats were eliminated because they failed to catch a mouse. Of the remaining cats, 27 had stripes and 32 had one black ear. All striped cats with one black ear got to the final. What is the minimum number of finalists?
What is the minimum number of finalists? So first off, we need to look at finalists. So in the finalists, there are all of the S plus black. Let's just say the S plus B means that they both have stripes and they have one black ear. And there are also only S, so only striped, but there's only some of them. It didn't say that all of the cats that had stripes had to go in. And there's also only black ears. So now we look at this, and it's asking for the minimum. So like since only some of the stripes can get in, we could say that the amount of stripes that get in are 0. Well, that is to say only stripes is 0. So you can cross it out. And only black ears, we could also cross that out because it's not necessary they are in the finals. But they say that the cats with both stripes and a black ear have to go to the finals. See, first off, we start off with 66 cats, and then minus 21 is 45 cats. And then in the 45 cats, we have to figure out how many are stripes and black ears. So there's a useful way of doing this, is that you do 32 plus 27 minus 45 equals the amount of striped black ear cats. But how did we get there? So let's just prove this. So in the striped cats, we know that there are only stripes, let's call only stripes S plus stripes and black, SB, equals 27. And then we have B plus SB equals, 32. Right. So we have these two. And then we see that 45 is actually S plus B minus, no, it's just S plus B. Right. Okay. So now if we were to look at like the striped cats and the black cats, if we add them together, we get SB 2 times SB plus S plus B. Oh wait, yeah, the 45 is the number of only striped cats, only black cats, and both striped and black-eared cats. So then we have 2 times, since like if we add the two equations together, we have 2 of the SBs, and we also have an S and a B, which equals 27 plus 32. Right. So if we were to try and find what one SB is, see, we can break down this 2 times SB to SB plus SB. And we see that SB plus S plus B is equal to 45. So we get that SB equals 32 plus 27 minus 45. All right, so now we've got that figured out. So now let's continue. So the 32 plus 27, how much is that? That is 59. 59 minus 45 equals 14. So that means the minimum the number of finalists of Miss Cat 2013 is 14 cats. Okay. Now next one. Question 21. Yuki, could you please read the question?
Aaron, Bern, and Carl always lie. Each of them owns one stone, either a red stone or a green stone. Aaron says, "My stone is the same color as Bern's stone." Bern says, "My stone is the same color as Carl's stone." Carl says, "Exactly 2 of us own red stones. Which of the following statements is true?"
Okay, great. So we have Aaron, Bern, and Carl, the liars. And Aaron's statement is my stone is the same color as Bern's stone. So A's stone is not equal to B's stone. And then Bern says my stone is the same color as Carl's stone. So B is not the same color as Carl's stone. And Carl says exactly 2 of us own red stones, which means since Carl said exactly 2 of us own red stones, that means it's not true. So there could be 3 green stones, 0 red stones, 0 green stones, 3 red stones, or 2 green stones and 1 red stone, but just not 2 red stones and 1 green stone. Okay, so now looking at this, we see that A is not B is not C, which means B is different from A and C. We see immediately that if there was 0 of a type of stone, then that would not suit. Because, for example, if we had 3 green and 0 red, then that means all 3 of them had to have green stones. But since A's stone is not the same as B's, which is not the same as C's, then that means it won't work. It's a paradox. So we can cross these two out. So now we have 2 green and 1 red. So if B is not equal to either one of these stones, then that means B is the odd one out. So B has a red stone. And A and C both have green stones. So the first statement is true. Aaron's stone is green. Alright, now question 20. Sean, could you please read question 20?
Okay, wait. In the squares of the 4x4 board, numbers are written such that the numbers in adjacent squares differ by 1. Numbers 3, 2, and 9 appear in the table. Number 3 is written in the top corner as shown. How many different numbers appear in the table?
Great. So we have 3 here. So if 3 is there, then we could have 2s or 4s. And there must be a 9 on the table. So first off, if like one of the adjacent squares is 2, we could have like 2 here. Or like we could have 2 2s. And then after that we could have 1s or 3s. So let's just say there were 3s. And then we have 4s, 5s, 6s, 7s. But if you look now, we can see that 9 cannot appear on the graph if we use 2s right after the 3s. Because then we will have to go from 3 to 2 to 3 to 4 to 5 to 6 to 7, which doesn't leave room for 9. Alright, so now that means let's just use 4s. So 3, 4, 4, 5, 5, 5, 6, 6, 6, 6, 7, 7, 7, 8, 8, and then 9. So this works. It's asking how many different numbers appear in a table. 1, 2, 3, 4, 5, 6, 7. That's 7. Alright, thank you. Alright, now question 18. How many pairs of 2-digit natural numbers have a difference equal to 50? So first off, 2-digit natural numbers. So from 10 to 99. So let's say there was A minus B equals 50. So how many numbers could A be? So we know that A has to be larger than 50. So it could be 50 all the way to 99. And B has to be smaller than, so first off, and then B has to be larger than 10. Larger or equal to 10, because it's a 2-digit number. And it's also smaller than 100. All right, so first off, looking at A, we have 50 minus B equals 50. So that means B would have to be 0, but since B couldn't be 0, and its minimum value is 10, let's just say we use a minimum value. That means A's minimum value is 60. So it's not 50 to 99, it's 60 to 99. And then A's maximum value is 99. 99 minus 49 equals 50. So that means B's range is 10 to 49. So then, well, how many numbers are there between 10 and 49? Well, if we subtract 9 on each of the numbers, we get 1 all the way to 40. So there's 40 numbers from 10 to 49. And that's how many pairs of 2-digit natural numbers have a difference equal to 50. From a wooden cube with a side 3 centimeters, we cut out the corner a little cube with side 1 centimeters. What is the number of faces of the solid after cutting out such small cube at each corner of the big cube? Alright, so for example, if we take any face, so this is before it was 3 by 3, and we cut out 1 by 1 cubes. So then this is what it looks like on any face. It looks like a plus sign. So then how many plus signs are there? There are 6 plus signs because there are 6 faces on a cube. Plus, alright, we see that in the figure, each corner of the cube gives us 3 extra faces. Which means that for every corner, 3 extra faces appear. So since there are 8 corners, 3 times 8, and this equals 30. Right. So next one. Max, David, and Peter competed in an ice cream eating contest. Max ate 6 scoops in the same time as David ate 4 scoops, and Peter ate 5 scoops. Max ate 18 scoops in half an hour, so times 3 is 18. Together. So that means you have to multiply 3 to all of these 3 numbers because, like, for example, this is how many they eat in 10 minutes. For every 6 ice creams Max eats, David eats 4 scoops, and Peter eats 5 scoops in, for example, 10 minutes. Wait, oops, my bad, sorry. Advertisement. Okay, well, I'm back. So anyways, we could say that, like, this is 6 scoops per 10 minutes, and 4 scoops per 10 minutes, and 5 scoops per 10 minutes. So if you multiply 3 to each of the scoops, it'll be how many they eat in 30 minutes. So 4 times 3 is 12, 5 times 3 is 15. So if we add them together, we get 45. Alright, next up, we have this big square. Alright, so for this square, how many different squares of any size can you identify in the picture? So first off, 1 by 1s. There are 13 1 by 1s. 1, 2, 3, 4, and 9. Plus 2 by 2s. So with 2 by 2s, we can't use these blocks because they have length 3. Which means that we can't use these blocks because they're saluted from the rest of the 1 by 1s. So that means how many 2 by 2s are there? Let's look at the centers of where the 2 by 2s can lie. So the centers could be here, 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 and here. They have to be intersections of lines. And we see that the only squares that can be included in the 2 by 2s are these squares. So that means there's 4 2 by 2s plus 3 by 3s. So for 3 by 3s, we have 1, we're using the big blocks now, 2, 3, 4, and 5, the center one. And next, we have the 4 by 4s. So for 4 by 4, we see that the entire figure is 5 by 5, which means that the 4 by 4 have to take up a corner of the 5 by 5. No more, no less. So the 4 by 4, we have 1 4 by 4 here, 2 4 by 4s, 3 4 by 4s, and 4 4 by 4s. So for each of the corners, so that's 4 more. Plus a 5 by 5, that's 1 5 by 5. Because the entire square is also a square. So 13 plus 4 plus 5 plus 4 plus 1 equals 27. Alright. Matthew is catching fish. If he had caught 3 times as many as he actually did, he would have 12 more. How many fish did he catch? So first off, if he had caught 3 times more fish, so let's say the amount of fish he caught was F, it will equal the amount of fish he caught plus 12 more, so he'll have 12 more. And so this is simple algebra. We get 2F equals 12 and F equals 6. Right. It was just some algebra. And then Anne rides her bike throughout the afternoon with constant speed. At the beginning and at the end of the route, her watch shows the time, as in the diagram. So first off, at the beginning, it shows 1:30. And at the end, it shows 3:30. And it is split into thirds, which means that the entire journey took 2 hours. So 2 hours divided by 3 is 40 minutes. And then it's asking for the first third. So for the first third, we do 130 plus 040, which basically it's basically like this. And this is it's like base 60 because we're using these two to add together, but if it's larger than 60, that means the 60 becomes a 1 in this column. The clocks are all the clocks we use are in base 60. So 30 plus 40 is 70. And then since 70 is larger than 60, 70 minus 60 is 10. And then we have one more here because each hour is 60 minutes. So 1 plus 1 plus 0 is 2. So 2t. The minute hand. So the minute hand is D. D points to the minute hand points to the 10. All right. Okay. Number 12. Wait 1 second. Number 12. Mary shades various shapes on square sheets of paper as shown. Which of the shapes have the same perimeter as the sheet of paper itself? So, well, you guys could do this yourself. So, once you get how you do it, it's pretty self-explanatory. So, for example, if we have this shape here, then we can move this side up over here. So basically, it's displaced. And we can also move this side here. And we have the same perimeter on this part, which means that this shape has the same perimeter as the square. And then, for example, if we have this shape, then we can see that we can move this side up here. We can move this side up here. And the rest of the perimeter is the same. But these two sides are not these four sides are not accounted for, which means the shape has a larger perimeter than the square itself. And so on. So the answer is C if you just look at them carefully. Right. Number 11. Which of the following pieces covers the largest number of dots on the table? So we know it's basically like a chessboard, so that let's just say the dots were black squares. So alternating black squares. All right, so we have answer A, which the lines don't really matter actually, because they're just trying. It just looks kind of confusing. All we matter is the dots they cover, the amount of dots. So let's say the big white circles are the dots they will cover, and let's say black dots are the places that they don't cover. So this is actually what A looks like, the configuration of A. So now we see that in the first, we see that for A, in the first row, there's big dot X, big dot, which is basically, it covers 3 dots. And since it's a checkers board pattern, the maximum amount of dots it can cover is 2. And then plus another 2 down here, because since it's checkerboard pattern, the dot could be here and here and here and here. So it's another 2. So A can cover at most 4 dots. And then B. So B, let's draw this this type of figure again. So X O O O, no X O O X, and then let's see, O O O O, and then X O X X. Okay, so looking at this configuration, we see that, we have the 2 dots up here, but the 2 dots are adjacent. And in a checkerboard pattern, there are no directly adjacent dots. So for example, if we have a dot here, there's no dots in this square, this square, this square, and this square, the adjacent squares. So which means there's only one dot in this row, and it doesn't matter which one of them. And there's a maximum of 2 dots at this row, and there's a maximum of 1 dot. So 1 plus 2 plus 1 is 4. So we can continue the process, and then we find that in C, since in the first row there is a dot dot x dot, there could be 2 dots. It could be covering 2 dots, and then we have dot x, and that could also be covering 2 dots at most. And then we have x, x, x dot, so that's 1 dot, so that's 5. So C is currently the highest, C covers the highest amount of dots right now, currently. And then we have D. So D is dot, 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 x. We don't really need to draw the other x's on this side. So anyways, so up here, if we have 3 adjacent dots, then it could cover 2. It could cover like 2 of them. And then there's also 3 adjacent dots here. But note, if we have a 2 by 3 chessboard, there can only be 3 shaded, which means that if there are 2 up here, there's 1 down here. And then since these 2 are adjacent, the only amount of dots that could be covered is 1. So 2 plus 1 plus 1 is 4. And then the last figure, we have dot dot x dot dot x x dot dot. And then so we can basically do the same thing. There's 1 here, and at most 1 here. So that's 3. Which means the answer is C. Alright, so looking at the other questions, I think I don't really need to explain them. They're quite more self-explanatory than the other questions. So now we can look at some fun problems. So repairing a chain. Have you guys figured out how to do the repairing a chain? Chat. What? How? Wait, 1 sec. Somebody said something in the chat. Alright, let me see. Okay, you guys haven't figured it out. Alright, so do you guys want me to tell you guys the answer? Okay, sure. Alright. Alright, time for answer time. Annotate. And now, great. Okay, repairing a chain. Remember what the problem was? So basically the problem was like there were a bunch of chains, and then you had to like connect them together into one long chain, and then he wants to do it in 6 operations instead of the usual 8 operations. So then see, we have one chain here. So if we break apart the entire chain, then we get, so we broke apart the entire chain. So that's 3 moves. And we have 3 broken chains. So that means, so see, the first, let's just say we use the index numbers. Chain 1 can connect 2 chains together. So like 4, 5, 6, and 7, 8, 9. So 1, 2, 3 connects to one of them, and then 1, 2, 3. So that's 4 moves. And then if we want to close this chain, then we can connect it on with this chain and this long chain, which means that's connect 1 and then connect 3 more, the 10, 11, 12 chain. And then that's 5 moves. And then at last, if we connect 1 chain and then connect 3 more, the 13, 14, 15, we get the entire chain. So that is 6 operations. All right, and now time is almost up. We have 3 squares. Take 8 small sticks, 4 of which are half the length of the other 4. Make 3 equal squares out of the 8 sticks. So you guys can keep thinking about this problem as time is up.